Hello and welcome to the YouTube channel Tech Guru Gautam Prasad. This is yet another video in which I am going to tell you about the different parts of the DC motor. DC motor uh, is a equipment that comprises of rotor and a stator. Apart from that, there are many parts that you need need to know. And here you can see this is the armature part that is also called rotor part, and that rests on a shaft, uh, and this shaft rests on two bearings on the two sides of the motor, and these bearings are supported on the end covers. This is one side of the end cover, and the other side is on this side. And for the cooling purpose, this motor has got a fan which rotates, which is installed on the shaft of the motor. So when the motor rotates, this fan automatically starts rotating with the rotation of the motor and keeps on cooling the motor. It has got its own circuit, air circuit, uh, uh, which keeps circulating the air so that uh, this maintains the ambient temperature of this motor and does not overheat. This is the conduit box in which the terminals are kept. You have gaskets for proper sealing so that it is no uh, ingress of dust or the moisture happens that distorts the connectivity of electrical connectivity of the motor. You have draining pipe for the grease. Extra grease can be drained out from this draining hole. You have shaft, you have bearings, you have grease inlet, and rotor laminations can be seen on this rotor. This is kept laminated because the current in the armature conductor keeps varying. It is commutated, but the nature of the current in the conductors of the armature are alternating in nature. So, in order to take care of alternating nature of the current, the rotor has to be laminated, and it is kept laminated to reduce stresses loss and eddy current loss. So lamination is done more and more for reducing the eddy current, and hysteresis is minimized. Hysteresis loss can be minimized by using proper type of the material that is called silicon steel. Let me make it pretty clear. So you have insulation for keeping the pole winding insulated from the um, body of the DC motor, and these poles are wound, and this winding, develops the when it is fed with the DC power, it develops uh, it turns into an electromagnet and generates the field. In this field, this armature conductor rotates, and again, rest of the thing can be seen in the case of the two videos that I have made separately. There, this principle of working of DC motor, and that has been explained in a very detailed manner. So you can go through those videos. I'm not going to discuss the same thing out here. This is the I volt that helps you in lifting the motor even you are going to install it, or you are going to remove the motor from the place where it is installed for the repair and maintenance purpose. So this is the foundation place for the foundation bolt, and on all the four sides this foundation bolt arrangement is there. Holes are there in which foundation bolts are tightened, and it is properly leveled so that there is no imbalance occurs. So leveling and alignment is the part of the installation process of the motor, that is taken care of at the time of installation, because slight misalignment can cause damage to the bearing, can cause damage to the shaft or entire setup of the motor. So this alignment and leveling and alignment is taken well care of during the installation process of the motor. Now, here also some further parts have been discussed, like you have got an air gap between your poles and the rotor. So, finer the air gap, better will be the response of the motor. That has to be, because the locking between this interaction between rotor magnetic field and the stator magnetic field will be very fine. So, the response of the motor becomes very excellent in that case. So you have pole shoes, and you have armature. You have yoke on which the full body of the motor is there. Yoke, path of the magnetic field through the you know yoke of the motor, and this is the teeth teeth on the armature commutator, armature commutator, and you have field winding, armature winding, and so forth. So the basic parts of the DC motor has also been shown here. Here the carbon brushes have been shown. You have been shown the commutator. You have been shown armature winding. You have been shown armature and air gap between the armature and the poles, and frame of the motor, and of course a stator and a stator winding. So that is what an entire DC motor has, and let's try to understand the parts uh, in with the help of this three-dimensional diagram, where you can see this is the removable casing base for the rigidity. This part is bolted through the foundation bolts, and this is the end cover. This part is terminal box. This highest quality magnets for increased motor efficiency on the poles. Armature connections fused for reliability and low resistance. And this connection is talking about the connection of the rotor winding or the armature winding on the commutators. So that basically betters the response of the motor. And here the rotor part, you have the winding of the motor, dynamic balance of the armature for the smooth operation. After the completion of this motor, there is a dynamic balance test carried out on the motor, so that that tells the manufacturer that its rotor is properly balanced on the shaft. If it is not, that has to be taken care of in a due manner, because that affects the functioning of the motor in a proper manner. So alloy end plate to prevent corrosion, uh, the ingress of the humidity and the dust is basically avoided by this end cover. And you have end cover on this side also. You have fan for the cooling purpose of the motor. That all has been discussed. Here the another part is, this is armature, this is the frame. These different views will definitely make your understanding better. So this is the field pole bolt, uh, with the help of which it is bolted. This is cut view of the stator part of the motor, and armature has been shown separately. So this poles field pole that is laminated is inserted in this coil, and this coil is connected to the DC source. Here also different parts of the DC motor. Basically, it's an universal motor, not only DC motor. So this universal motor is something that can run on DC and AC, both the types of the supply. That is why it is called universal motor. So here is a universal motor on which different parts have been shown. This is your commutator. These segments are connected with the winding of the armature, and this is the armature part. This is the pole winding, and the pole. This is the pole winding. This is pole face, and this is the mm, brush holder and a brush. You can see this brush is resting on the commutator from both the sides, and these are the supply is fed to this uh, these brushes, uh, especially these terminals come out from here, and they are connected to the power supply, DC or AC, and this motor runs. So you have mica separators in between the commutator segments, so that they stay separate from each other, and the commutation happens smoothly. So I'm moving to the next slide, which is again showing you the commutator, three, one large size commutator, medium size commutator, and a small size commutator. So here there is a big, huge DC motor of 1000 HP, 500 volts, and 1580 amperes, and 850 to 100 RPM. Make it General Electric. This is a DC motor, and you can see here a big size of the DC motor armature. You can compare with the height of the people standing by the armature. This is quite a huge armature, and so huge is this commutator surface, and multiple brushes rest on this, and to carry out a smooth commutation. Here also a huge motor, DC motor armature has been shown, that has got poles and interpoles. Basically, interpoles are inserted in between the main poles to uh, smoothen the process of commutation. There is something called armature reaction happens in the case of huge motors and small motors as well, and that has got you have got different ways to deal with armature reactions to improve the process of commutation. So if your process of commutation is not smooth, the sparking at brushes will start taking place, and that will, erode the uh, brushes, uh, brushes, graphite brushes, and its maintenance will increase. At the same time, it will also erode the commutator surface. That is a costly process to repair. So both the things have to be taken care of, and this can be taken care of by inserting. One way is to use interpoles in the case of huge motors, big size motors, and that smoothens the commutation process. You can see here the electrical connections of the interpoles. They are connected in series with the armature, so that they carry the full current that armature carries, just to cancel out the effect of the armature reaction. And this is one of the most powerful method to counter the effect of armature reaction uh, in the in the process of the motor, or in the process of the generation of the DC power. Uh, so in both the cases, this commutation is required. You can see here on the on this is in this picture that number of brushes have been used. They are resting on the commutator, and these lugs are connected to the terminals through which it is fed the DC power. So here also one huge size of the motor has been shown, and you can see the pole connectors are there. Just they are getting connected through these connectors, and interpoles are also there, and brush holders and gears are also there. Yeah, so that completes the discussion of the DC motor. Thank you very much. I will suggest you to stay tuned with my channel so that you keep on getting the notification for such useful videos. Thank you so much and stay tuned.